Hi everybody. Today we are going to talk about electron configuration. So the first thing you need to make sure that you have done is to label each of your rows on the periodic table with numbers 1 through 7. Once you've done this, then you are going to make sure that you have your blocks labeled. So the first block here is the first two columns, and this is the S block. Helium should be a part of the S block, so you just kind of have to remember that. The reason that is on the right side of the table has to do with properties, but for electron configuration purposes, it should be considered part of the S block. Okay, I'm going to use a different color here. Okay, for the next block, right here, this is the P block. So P block. And I would definitely label a periodic table if you are new to doing this. All right, different color. So that is the P block. The D block is a little bit trickier. It is this kind of sunken down block right here. So this is the D block. But these first two elements right here, lanthanum and actinum, they are part of the D block. So this first row goes right here. So lanthanum would go right there. And then actinum, that entire row would be fitting in right here. So these are, lanthanum and actinum are actually part of the D block. And then for our last section here, it's down here, and it's the rest of the elements at the bottom, and that is the F block. Okay, so when you're doing electron configuration, you have to remember that you're doing this like you're reading, and so you always start at the very beginning, the top left of the table, and you go from left to right, and you have to finish an entire row before you go to the next row. All right, so now we're going to do an example. So the first example that we're going to do is carbon. And so carbon is right here. That's the element that we're interested in. And so we're going to start at the beginning of the table, and we're going to write terms until we get to the element we're interested in. So the way we do this is the first part of your term is the row that you're in. So we're going to write a 1 because we're in the first row, because this is where we're starting right here. And S is the block that those elements are in. And then there's 2 of them, because remember, helium is supposed to be right here. So there's 2. The number of elements is your little superscript. So now I am completely done with the first row since I've done both elements. So now I go to the second row. And anytime you switch rows, you're going to write a new term. So a 2, and then I'm in the S block again, and there's 1, 2 elements. So that is my superscript. Now I've got to keep going all the way across because I'm still in the second row. But when you switch blocks, you have to write another term. So now it's 2P. And then I count over to the element I'm interested in, which is carbon. So 1, 2, and that is my superscript. Now remember, when you add all of the superscripts together, 2 plus 2 plus 2 is 6, and that should equal your atomic number for carbon, which is 6. And that's one way that you can check yourself. Okay, so that's a pretty easy example. Now I also want to tell you that the entire D block has been sunken down one level. So what that means is when you get to scandium here, it's actually going to be a 3D, not a 4. And then, okay, so it's one less than the row it's in. So yttrium would be a 4D, and then lanthanum would be a 5D, and actinum would be a 6D. Okay, so that whole D block is that way. Now, when you get back to the P block, it goes back to the row it's in. So this would be a 4P, a 5P, a 6P, and a 7P. Now let's talk about the bottom. So that means that lanthanum is a 5D1 element, and actinum is a 6D1 element because they're the first ones in the D. But when you get to cerium, which is the next one in the row, it is actually the F block, and they are 2 less than the row that it's in. So then cerium is going to start with 4F, and thorium is going to start with 5F. Okay, so that's important to note as we continue to go through the table. So now we're going to do a different example. This example we're going to do is nickel. Okay, so for nickel, once again, I start at the very beginning of the table with a 1, S, and 2 because there's 2 elements. And then I go to the next row, which is 2, and my first block is S right here, and I have 2 elements, so that's a 2. I go all the way over to my 2P block, and I count 1, 2, 3, 4, 5, 6. So that is my superscript. Now I'm done with the second row. Then I go to the third row, and it is 3. I'm in the S block first, and there are 2. Then I go all the way over. You can't skip. You got to go in order of atomic number. 3p, and I count 1, 2, 3, 4, 5, 6. And now I'm done with that row. Then I go to 4s. There's 1, 2 in the S. And now I get to D and I write 3D. And then I count 1, 2, 3, 4, 5, 6, 7, 8. So remember to count the element you're in. Now, if you add up all of your atomic number or all of your superscripts here, it should equal your atomic number, and it does. It should equal 28, which is nickel. Okay, now those are pretty easy examples. It gets a little bit harder when you get down to the very bottom. So now we're going to do one of those examples. Okay, I'm going to erase my carbon and my nickel here. Okay, now we're going to go down and let's try Nd, neodymium. So Nd. So I'm going to start at the beginning again with 1s2 and then 2s2. You can see this is repetitive. Then 2p6, then 3s2, then 3p6, then 4s2. So now I'm here. And then 3d10 because I counted across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm back to 4p. Remember, you can't stick with 3p after 3d because you've already done 3p right here. So it goes to 4p, 1, 2, 3, 4, 5, 6. And then I'm down to 5s2. And then 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4d10. And then 5p, 1, 2, 3, 4, 5, 6. 5p6. And then 6s2. So I'm right here. Now, when I get to this part right here where the blank is, it's telling me that I have to go down to the bottom. So the 5d1 is filled first because it is technically in lower energy than the rest of the 4f's. So remember, you have to go in order of atomic number. So since this is 57, I have to go to 58, 59. I have to go through this entire row before I can go back up here. Now, in this case, I don't need to go back up because I'm stopping at neodymium. So I would write a 4f, and then I would count over 1, 2, 3. And that would be my configuration. And then when I add up all of my superscripts here, it should equal 60. Okay, now let's do one that's a little bit harder, where you have to come back up. So let's erase. Okay, so now let's do one that's in the bottom row here because that's going to make us come back up. We'll do MD. So MD, Mendelevium. I'm going to go kind of fast until I get to 6s2, then I'll slow down. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and then 6s2. Okay, so now I'm right here. So now 5d tells me I have to go down here, and I'm going to write my 5d1. And then, once again, I have to go in order of atomic number, so that means I have to do 4f next. And since I'm trying to get down here, that's the second row. That means I have to go through this entire row first, right? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 in that 4f. Okay, so now I'm at 71. So this is where kids get confused. At 71, I have to figure out, okay, well, where do I go next? Well, I have to find 72. So 72 is back up here. So that means I'm back in 5D. So I'm going to write 5D again. But this time I'm not counting the first box because I already did it. I'm going to start here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I add these together, it would be 5D10, but this one's filled first, then the 4Fs, and then the 5D9. Now I'm over here at 6P, and I have 1, 2, 3, 4, 5, 6. So 6P6. Okay, and then I go to 7S2. And now I'm at 6D, which means I have to go to the bottom row. So 6D1, and then I'm at 5F. So remember, if you get confused about where you are, follow your atomic numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5F12. And if you add all the superscripts together, it should equal 101. Okay, so hopefully this made some sense. If you get stuck, remember, follow your atomic numbers, and that should help you out as long as you've labeled your periodic table well.